300 million miles away, orbiting the Sun between Mars and Jupiter, lies an asteroid known as 16 Psyche. Over the coming years, scientists hope to study some striking similarities that this asteroid shares with our very own pale blue marble. It might be difficult to imagine what our planet could possibly have in common with such an object. The answer lies at the center of the Earth. It is believed that the Psyche asteroid is in itself the core of an early planetesimal left over from the creation of the solar system. Collisions with debris and other asteroids made Psyche into what it is today. It is rich in metals and could hold key answers about the properties and creation of Earth's very own metallic core. It is known to be over 95% metallic and has a diameter of about 140 miles at its longest axis. But other than that, not much is known about Psyche. Arizona State University and NASA scientists and engineers hope to change this in the very near future. In August of 2022, NASA plans to launch a mission to the metallic asteroid to study some of its properties. Based on the results, the next step is a possible return mission that would include the landing of a rover onto the surface of Psyche, the collection of surface samples, and for the safe return of these samples so that scientists back on Earth may unlock Psyche's secrets. NASA and Arizona State University challenged colleges and universities to develop a comprehensive mission from start to finish. At Michigan Technological University, 20 students stepped up to the challenge to try their hand at spacecraft development and mission design. Teams were arranged based on the 4 main phases of the mission: landing, sample collection, sample transportation, and sample return. Our team's scope involved ensuring the samples remained sealed, secured, and uncontaminated, as well as the transportation of these samples into orbit around Psyche, where they would be collected by a satellite and brought to Earth. The landing team developed a unique payload release mechanism to deposit the rover onto the surface of Psyche. The rover transportation team developed a one-of-a-kind surface traversal method using the low gravity on Psyche to their advantage. The sample collection team developed self-contained cylinders housing drill bits that collect metallic shavings from the surface of the asteroid. Our first challenge was to design a way for the sample collection team to be able to lock their cylinders containing the metallic samples into a vessel that would also prevent contamination. Using the premise of a common twist-lock mechanism, our team developed a thread groove with multiple locking points that would allow for the sample cylinders to be placed in and locked or removed completely with minimal effort on the part of the rover team's robotic arm. Due to the low gravity on the asteroid, these downward-facing grooves eliminate the need for the robotic arm to press downwards with respect to the asteroid's surface. As the cylinder is threaded into the base, the drill bit housed internally within the sample cylinder will encounter the small cone in the center of the base. This cone forces the drill bit upwards, which compresses a seal along the top of the sample cylinder. At the base of the small cone in the center of the cylinder receptacle, there is a small groove that holds a space-grade seal and prevents air and particle contamination once the cylinder has been threaded into place. This creates a contaminant-free, airtight seal within the entire cylinder housing. In order to verify that the invaluable sample-laden cylinders would not loosen under the extreme vibrations that occur during takeoff and orbiter interception, our team simulated the vibrational properties of the cylinder base. Further physical testing is required to determine the necessary level of damping and to ensure the safe return of these metallic samples. The final challenge for our team was to create a launch vehicle that would allow the sample-laden robotic arm easy access to the sample cylinder receptacles within, while at the same time incorporating all of the standard equipment and technology that would bring the vehicle into orbit around Psyche. Components housed within the launch vehicle include the bipropellant propulsion system and the corresponding oxygen and propellant fuel tanks, a gyroscope for attitude correction, a star tracker for navigation, reaction wheels for course correction, the power supply, dual motors that enable the functionality of a rack and pinion door, the long-distance communication device, and finally, the receptacles that allow the sample cylinders to be locked into place within the launch vehicle. In order to progress the overall design and ensure feasibility, our team recommends a few additional steps be taken. Manufacturing the cylinder receptacles out of aluminum by means of manual or CNC lathing or metallic 3D printing would allow for a more realistic approach to physical testing, as well as implementation into the overall design. This would also allow for more realistic vibrational testing to determine mode location and damping requirements.